Right, this is question 9, and it says, based on the introductory information, so that's what we're going to be looking at, step 1. When D was equal to 0, what was the relationship between Y and L? Right, we have to find D, we have to find it when it's equal to 0, and we have to find the relationship between Y and L, so that's going to be 4, that's going to be our answer, so it gets the asterisk. Alright, step by step. Based on introductory information, so that means we're going to have to read what the introduction says, and that's kind of down here. Right, so we know they determined g, the acceleration due to gravity. In each trial, the student suspended a spring from a stand and measured the spring's length. Okay, so we have L here, so L equals spring length. That's a terrible writing. They attached a mass to the suspended spring, so they just attached a weight to the spring, allowed the spring mass system to come to rest, and measured the length y of the extended spring. Okay, so y equals extended. And then they have the little diagram, and then they then calculated the distance d, so d equals distance, and it's y minus L. Alright, so we've got that information. So our answers are y equals L, y is 2 times L, y is L divided by 2, y is L divided by 4. Right, so we've looked at the introductory information. So we've done one when d was 0. So we've got this equation here, d equals y minus L. So d was the distance. So we're told here that d equals 0. So 0 equals y minus L. I've just plugged in 0 for d. And d is the distance, right? You can see it here. They're showing the distance. This is the short spring, and this is the extended spring, and it's just showing that d is like the spring extending. It's like it's tiny, and then it expands out when they put the weight on it. So d is the distance that the spring extends, right? So if and hopefully this makes sense, if the distance that the spring extends, right, is 0, then the spring doesn't extend at all, right? If d is how much it extends and d distance, if d equals the distance it extends and that distance is 0, then the spring didn't move. So it doesn't matter. It's not going to be, if y is the extended spring, there is no extended spring because the distance equals 0, right? So y is going to equal 0, and obviously everything's going to equal 0. Nothing's happening. You know, the distance is 0. So the spring has done nothing. So if everything equals 0, this is 2 times, this is the only one that makes any sense is y equals L, 0 equals 0, nothing's happened. So that would be answer choice A.